Alright, so I just want to draw your attention to a really small difference between the equation as given on your formula sheet and the equation which I have up here on the board. Okay, so when we start off using F is equal to BIL sine theta, or in this case nBIl sine theta, we're talking about the force on a single piece of wire, a straight conductor, something like this. Okay, and it doesn't take into account when we look at motors. Okay, motors aren't just one single loop of wire, they're multiple turns of wire, okay, or multiple loops of coil. Okay, so the force is amplified by those multiple loops, and we need to take that into account. Okay, so one of the first things you should do when you get into your examination is basically recorrect the equations which aren't entirely correct or entirely valid. So this is one of the equations which we need to correct alongside the transformer equation, which we'll talk about a little bit later. So with this equation here, our N, this is number of turns of coil. Our B, this is the external field strength, okay, and that's going to be a magnetic field. So the external magnetic field strength, and this is measured in Tesla. I is the current flowing through the wire. Okay, so this is current through the wire, measured in amps. And L is the length of the conductor, or the length of the wire measured in meters. Now this angle here, this angle is the angle between the current carrying conductor, or the wire, and the magnetic field. Okay, in all of these four scenarios up here on the board, the angle's 90 degrees. Okay, and the best way to try and figure out, does this angle actually matter is by using your right hand palm rule. If you use your right hand palm rule, and sine theta, or theta here, is the angle between your thumb and your index finger. Okay, so if you can model these scenarios without changing the direction of your thumb, if your thumb is always perpendicular to your magnetic field, then theta is going to be 90. However, if you come across a scenario where you can't model it using your hand, with your thumb and your index finger perpendicular to each other, that means you need to change the angle. Okay, we'll go through a scenario where that actually happens.